So yeah, thank you very much for joining the IO.NET Virtual Meetup with Scott and Glenn. Really appreciate you guys taking the time to come and speak to the development community over in the UK. Just as a very brief intro, because I know you haven't come in first, I'm Michael and Ellie, who are hosting today, work for IO Associates, IT recruitment company based in the UK. If you want to have a chat to us, there's our details. Yes, questions. Scott said more than happy to put the questions in the chat box throughout. We do send a survey after. Feel free to fill it out to try and make it better meetup. Yeah, without further ado, we'll leave it to you then, Scott. You're okay to share your screen now. I think I've made you co-host and everything.
Cool. Well, let me do the magical screen share thing. Let me know when this comes through. Can you see it, or is it not working?
Yeah, I've got it.
Awesome, cool. So thanks for having me back. I'm Scott Hunter, VP Director of Program Management at Microsoft, and I've got with me Glenn, Principal Program Manager. Glenn drives all of the frameworks that live on top of core.NET. And so, think of ASP.NET, think of Entity Framework, and whatever else, Orleans, which is something we haven't talked about a lot, but it's something that we're going to talk more about in the future. And so he's my primary person to think about microservices and cloud native, and that's something we wanted to talk about today.
It just causes as much trouble across the stack as humanly possible. It's generally my thing.
And so what we thought we'd do today is I threw a couple slides together real quick, but really what I was thinking more would be fun to do is just have Glenn and I do some fun demos of some .NET 6 stuff and some Project High stuff. And we can answer questions about, cloud native. I can even talk a little bit. If you don't post this until, that's probably too far. I was going to say, if you don't post this for a month, I could talk about some NDA stuff, but that's probably pushing my luck there. But I will talk about some of the challenges of hosting. Glenn and I have been actually demoing cloud native in .NET for probably a year and a half or two, and it's actually hard to run cloud native apps in Azure right now. And we'll talk about that a little bit. And we have some tech coming down the pipe that's going to solve that. But it is interesting that we've been talking about this thing for a while, and I'm like, Kubernetes is really the only thing we can run our apps on right now, Glenn. There is no simpler way, and so that's something we'll have to work on.
Yep.
Couple just quick intro slides that I show all the time. .NET's been kind of amazing because we've been on this journey of really letting you do anything you want, whether it's desktop where we started, web. Glenn drives a bunch of that. There's the cloud tech, and we're going to show some of that today. Mobile is obviously Xamarin, which will turn into Maui. Gaming is Unity. IoT is some of the core bits that we have, and AI is ML.NET. And so, we have no matter what you want, we got something for you. Somewhere in the platform here. We're over 5 million developers that we measure through the Visual Studio family of tools, which means there's probably more than 5. In fact, I think the number was 5.3 was the highest I saw it. But we're projecting it will be over 6 million into next year. We run a call, at least I was on a call recently with Scott Guthrie. And if you don't know who Scott Guthrie is, he's kind of, to me, the father of ASP.NET. And, he left us in 2010 to go work on Azure. And we were on a call with him recently. And, .NET's, if you don't know this, .NET's 20-year anniversary is going to be February the 14th, Valentine's Day next year. And so we're going to have a bunch of cool stuff around that when it happens. But we're on a call with Scott Gu. And he's like, and we had just sent him an email recently about the fact that we had been the most loved framework 2 years in a row, 2019 and 2020, on the Stack Overflow developer survey. And Scott literally said this. He goes, this is unprecedented. He goes, most things that are 20 years old aren't number one at anything. And he was making a joke that it is kind of amazing that .NET had an awesome start. It kind of shrunk a little bit in the middle of its life, and now we're back on a great growth path again. In GitHub, the Cloud Native Computing Foundation measures the highest velocity projects, and .NET is actually #1. We say top 30 here. That's being kind. If you follow that link at the bottom of the screen, which you can't type because it's too complicated, maybe I'll put it in the chat. We actually are #1, which is pretty cool because we open source super late. Top 5 language. You know, you probably heard us talk about this forever. We're faster than everything, and a lot of new students into the system. This is kind of like hitting the performance again. You know, comparing Java, 5 million more, Node.js, 6.5 million more, 6.4 million more. Super happy about the gRPC, which I think is a cloud native technology that's kind of important to us because it lets you actually build services and call them across a variety of languages. And my fellow friends on the C++ team are upset that we in .NET with garbage collectors running still can beat the C++ tech there. This has been something we've been pushing on for a while, and please help us keep pushing this. This is basically, .NET Core 3.1 had 3 million users in its first 6 months. .NET 5 had 3.6. This is important to me because we don't want you to be on like .NET Core 2.1 or 3.1. We want you to be on the latest versions all the time to take advantage of all our newest features. No more of this .NET framework. Hey, we'll stay on the same version for a decade, please. And then next is, I put a slide in, if you're building web apps and services, we're going to talk about microservices today. Why .NET? Well, it's the fastest web framework on the planet. We have flexible deployment with Linux and containers. Likely by the end of this year, early next year, Linux will make up about half of all of the .NET web apps and services that are built, which is kind of amazing since we didn't have any Linux support until just a couple of years ago. We've been working on every release. We're working on finding ways to shrink the size of your applications and the amount of memory they use. And we took some steps this year again, and .NET 7 will take even more steps. And we have a bunch of awesome tools. OpenAPI, anything that does OpenAPI, we can basically expose OpenAPI for any APIs that you build. We can also consume OpenAPI from other applications, and from that we can actually generate C# clients for you on the fly. We have the ability from the Visual Studio family of tools. You can actually publish an API if it has if it supports OpenAPI, and we can automatically provision it and set it up for you in Azure API Management. And then of course WSL2. Which is some amazing tech. It lets us basically run a proper bash shell on a Windows machine. And so you can basically do native Linux development on Windows, still using all of our amazing tools. The WSL tech is the same tech. I'm not saying it's not public, but we've been showing that Windows 11 will let you run Android applications natively on the desktop. That's using a flavor of WSL because Android runs on Linux. And so we can basically use a flavor of WSL to let you run those apps native on the desktop. And then obviously with Blazor, we've got full stack web development. Whether you want to have static web apps that run entirely in the browser, or you want to have server-side applications, we support all that stuff. And then before we kind of get into the meat of this thing, I'll just kind of land with .NET 6 is going to ship in about a month. And it starts closing our goal of having a single SDK, a single BCL, unified toolchain. That means using the new project system everywhere. Awesome cross-platform native UI with Maui, cross-platform web with Blazor and Blazor WASM, a bunch of cloud native investments. And Glenn will demonstrate some of these today with some of the stuff we've been working on for APIs. And then of course, more performance and productivity improvements as well. We're not going to land the message 100%. The Maui tech ends up running a little late for us, and so it's going to RTM probably in February or March of next year. I think we were just overzealous in thinking we could ship all that stuff. I mean, we had to take basically what was the old Xamarin. We had to move it to use the same BCL that we use everywhere else in the product. That means your iOS, Android, Windows, and Mac apps are all using the core BCL. We added Windows and Mac as supported platforms We moved all of it to the new project system, and then we also made the applications all support a single project, meaning you don't have to have an Android project, an iOS project, a Windows project, a Mac project. We can surface all those together under a single project, and so that's a lot of stuff for us to go try to pull off in a single release. And it kind of pushes to the extremes. And so we're gonna ship those bits still in the preview channel with the .NET 6 launch in November. RTM those things probably early into next year, and then hopefully I think you'll see .NET 7 is going to be when this tech's going to really shine, because we have some work we're still going to continue to do on size on disk and startup perf and stuff like that. But it is cool to me that we're kind of back to where we started with a single platform, except it's not like 1.5 gigs. It can run side by side, works on all the OSs. So it's been an amazing journey. So with that, I'll talk about a few of the other features. Glenn's going to show this bunch of C# features. I'll let you write less code. There's places where lambdas would require typecast. That's gone. We have global usings to get rid of usings. We already had top level statements, but Glenn's going to show you how you can build an API in just 2 or 3 lines of code. .NET MAUI is going to let you build native apps on mobile and desktop. And we're also going to let you put Blazor inside of that as well. So you can build a desktop application that is a Blazor app that still has full access to the hardware of the machine. Minimal APIs. Glenn's going to show that. We've added Apple M1, and we've added ARM64, Windows ARM64 support for WinForms and WPF. And interestingly enough, WinForms has been one of the biggest growing platforms on top of the newer .NETs. And that's basically, we're seeing customers start to move their applications from .NET Framework to .NET 5. Hot reload is throughout the entire product, but I will warn everybody, hot reload is something it'll take us 2 years to actually finish that journey. We have a bunch of it now, but what we really want you to do is use it and tell us where it doesn't work, and based on that feedback, we'll update things. Now with that, let's move on to the microservice part of this thing. So this is kind of a slide that we put together a couple months ago, and it kind of talks about the difference of how these applications are kind of put together. So you can see the monolithic, app is in that area, and the way that you scale, I think there's an animation here. Yeah. The way that you scale that thing is you basically go take that thing and stick it on as many virtual machines as you can. And so you can see that large all-inclusive application. This sucks from many standpoints. From a development perspective, if you're working on a monolithic application, it means everybody's in the same repo, working at the same time. If I make a change somewhere, it has to filter through the entire application. It ends up making us ship at a slower speed. And it also means that in many cases we're bottlenecked by some parts that we cannot scale. Like if you're tied to a SQL database, well, you can go get a bigger SQL database till you can't, and then you're stuck. And so the cool thing about having a microservice is it means you're going to break the app up into more pieces. And I think if I animate over here, you can see we can go stick those pieces across a variety of hardware, which means it's easier to scale. It's easier to use less resources, because I could decide one part of my app needs more resources, one needs less. But it also means that each of those parts can be independent teams. And that's one of the primary reasons that we kind of go this way. Now, Glenn and I both will laugh with you and tell you that we had customers come in and they broke their apps into like 50 microservices. And it's like, please don't do that. You're going to then spend more time trying to deal with all the pieces than you are going to do with working on the actual apps themselves. So we find most cases it's like 3 or 4 pieces is a good number, not 50. And the next thing is, what are containers? And so, I've got here a chart kind of showing what virtual machines are. We all know how this works. In one of my previous jobs, I did this kind of stuff. It's like, let me go, build a virtual machine. I'll go stick a copy of Windows on it. I'll stick all my stuff on it. These end up being big, monstrous things that are kind of hard to throw around the network. And then I think of a container, and the big difference over here is you notice that I've kind of decoupled the operating system here. I've got my binaries and libraries. That's my .NET 6 and whatever I depend on, and my app inside of it. And these can easily be floated on top of operating systems. And so let's go and really dig into this. And you can see here's a traditional VM kind of environment. I've got my hardware, my host OS. I've got a hypervisor that knows how to run virtual machines to virtualize the hardware. And the problem here is, in many cases, I might not be using all the hardware because I'm basically the VM is what it is. If I switch to containers, then basically I can take all these things and go, you know what? I want to utilize the hardware fully. So I'm going to move all of those over here. And so if you break your app into these containers that aren't bringing full operating systems with them, it allows us to more easily manipulate these things and move them around so you can actually fully utilize the hardware. There's actually a bug in this slide because it should actually make the green bar go further around. But and then of course you can turn off the VMs that you don't want. And the reality is, and we're only 1 year away from this, is a study that was done a while ago. By 2022, next year, over 75% of all organizations will be running containerized apps in production. So this is something that we should all be learning and figuring out how it works. And then of course, Kubernetes, which is something that is largely behind this growth. And if you don't know what Kubernetes is, it's basically the environment that manages and runs these things. And you can see that, a bunch of big companies, New York Times, Capital One, Spotify are using it. A cool part about Kubernetes is it is cross-cloud. Kubernetes works in Amazon, Google Cloud, and over here in Microsoft and Azure. And so we have some customers that actually need to, for regulatory reasons, run in more than one cloud. And so you can basically run these Kubernetes apps across those clouds. And it's also, it's open source, and it gets a lot of feedback and a lot of PRs from the community. And so it's a great platform. There's a bunch of negatives to Kubernetes, and Glenn and I will talk about them as well. But here is the, you can kind of see that you will describe to Kubernetes, what you want your application to look like. It's going to have a bunch of nodes. It's going to go and have a bunch of tech that goes and manages those nodes across things like this. And what I'll say here is, holy crap, there's lots of boxes. And somebody in your organization has to support this. And I can tell you, this is not what I want to do. Notice there's proxies, there's containers, there's managers, schedulers. Yuck. I mean, some of this is cool. Glenn and I were playing with some Kubernetes tech a few months ago, and we're watching it restarting one of our processes all the time. And then we're like, well, how do we figure out why it's restarting that process? Yuck. And so you're going to see us, in Microsoft and in .NET work to try to give you the benefits of all of this without the heavy cost of trying to manage this. Some organizations love this. We have some big retail companies that really like to use this stuff because they basically build their own fabric on top of this. And it makes them feel like they're in more control. But for the average developer, this is too much. You're welcome to step in, Glenn, and tell me I'm wrong.
I'm not going to do that.
What are our cloud native investments? First off, APIs. We want to have awesome APIs. I mentioned before, we have awesome support for OpenAPI. We have a REPL, so if you want to actually, be in Interloop, that's when you're actually running your application and testing it. You don't have to build a client to call it. You can just call it right from a command line interface that we built for you. We have client generation. We published to API management. We added gRPC a couple versions ago, and that was for people that wanted more of that traditional RPC style APIs, where you kind of define very strictly what the contract is between these things, and we will generate clients and servers for that as well for you as well, with world-class performance. We were just on a call, Glenn, just a few weeks ago, and talking about even maybe we still have a gRPC style API, but it isn't cross technology. The benefit of gRPC is it's cross technology, but that means that your types have to map to common types that work on all the platforms. There might be cases where you want to use, contract-based APIs, but have them still be all the native types in .NET. That means you can only stay in .NET, but that's something we're going to explore as well. Awesome support for Visual Studio with WSL, Windows Subsystem for Linux. Making single files, single exes. Glenn's going to do a bunch of demos on this on these minimal APIs. We've been building a reverse proxy here as well to host that you can host in front of your APIs. We're going to use that for a bunch of Microsoft services. And then we have Thai, which is something that we started off as a .NET only thing, and now it's actually a cross-language thing. It basically makes it where you don't have to do all this goop here. And this is funny, I left this in, Glenn, just for fun. This is Feather HTTP. This was an experiment that was run by some people on our team, it seems like about a year ago, where we'd go out and interview a bunch of developers.
Actually, closer to 2 years ago now.
Was it 2 years ago? Time goes by.
That's how long.
We actually interviewed people new to programming and showed them .NET, and then asked them, were they comfortable? And they were not, because our API tech built around Web API was designed for like enterprise class things with controllers and folders and stuff everywhere. And if you compare this tech to something like Node or Python, it looks like there's a lot of stuff there. And so this is a refactoring of some of this tech. It's one of our goals all along as we started the .NET Core journey, was to basically refactor all of the tech so you could use as much or as little as you wanted to. And so this is still using the same underlying tech, but it gives you a simpler way of doing it. And so this is actually an older, I know we can do this in less lines now, but it shows you this new idea of saying
features, this is better. This is as good as you could get with the features of the stack at the time we did Feather.
But no ceremony, using a lot of our new features. There's no classes, there's no mains, there's none of that stuff. You can always take anything you map here, you can always go paste that into a controller and it should just work. And this ships in .NET 6. And with that, maybe Glenn, I'll throw it to you for a second and let you share your screen and do a couple demos of minimal APIs.
Sure, I had to rejoin the meeting though, so no, that's just a warning.
You can make you presenter.
Yeah, no, it's okay. I think I am. I was just missed. I just, like a typical programmer, didn't actually read the error message. I just assumed I knew what it meant. Okay, so let me share my screen and then drag up an app in Visual Studio. Bam. How's that look? Zoop. So that is if any of you haven't seen this before, that is what that same effectively Feather demo looks like today. And so what this actually is file new empty. If any of you have used file new empty web in any time recently, this is what that template looks like today.
Hey Glenn.
And so, yeah.
You should just do file new console.
Yeah, okay.
We should really just hit the point and just show that this is one of the cool aspects of .NET to me is, we can change stuff. I mean, this is insane. This is go look at a traditional console application. Notice here, there's no usings. They're all replaced with global usings. There's no classes. There's no main. Just write to your code. The same way that people start with Node, or they start with Swift, or they start with many other things. Now we can do this in .NET. And we've done this for many of the templates. We're slowly trying to go through all the templates and change all of our defaults to use this kind of style tech.
Yeah, we started out with this kind of overarching idea of we called minimal APIs at the time that Marina Gaga and my team was kind of championing. And that turned into many things. And so, and most of them were far more wide reaching than just APIs, right? So we tend to just call it minimal now. We've probably got to come up with a better name as we spread through the rest of .NET. But the idea was, how can you take away the experience we were seeing when someone new to programming or new to .NET coming from an existing stack that had a different kind of initial syntactic complexity, how can we take away that initial shock that made them not want to continue, but also not create a dead end where you start building code that is like, that then becomes unmanageable and unmaintainable and things like that. And so ultimately what we ended up with is increasing the flexibility of our stack to be able to allow it to provide these super minimal experiences, and also allow you as a developer the freedom to be able to choose to organize your code in many different ways, that however you saw fit. If you're doing something that required 5 lines of code, it could take 5 lines of code, as opposed to some of our more historical stuff where even if you only needed to write 5 lines of business logic, you still needed the 40 lines of boilerplate to go around it, right? So now you have options and you can choose, is one of the big things that we ended up with. So this is the empty web app. And so minimal for web, at least, is broken up into a couple of parts, depending on how you think about it. One of them is basically a rejiggering, changing of the hosting model, a more minimal hosting model. So that's this, where we create you a default builder. We don't like require you to have a startup CS. We let you kind of mix those concerns into this class if you want. If you want to have a startup CS, you can still add the startup CS to this builder. It's the same as it was in the past. And so we kind of merge those concepts by default, and you can choose to expand it out again if you want later. This makes use of a global language feature called global usings. So there's no usings here, even though I can write some code. And because there's a set of kind of implied usings that everybody gets, I can add usings in here if I want, and you can customize what those implied usings are or turn them off and things like that in your like in your project. We have global namespaces. There's a namespace that just kind of exists globally that you can put your code in. And there's this is in kind of an implied program main. For those of you who have been using .NET for a while, there's kind of a pretend program main here, right? Because most of the time you don't care about any of that, to be honest, right? Like you don't really care what the program main, you don't need that program main method. You don't need the namespace the program main is in. You don't really care about any of that stuff. But from a concept overload standpoint, if you put yourself in the mindset of someone coming in, learning what coding is about, is it more important that they learn how to create functions and classes and have an endpoint that they can try out? Or is it more important that they get distracted by what the namespace is, or the 50 usings, or what static void means, or the args param array, or whatever, all the other various kind of syntaxes that end up floating around in your program main? And then you put yourself in the mindset of someone coming over from, say, a JavaScript or a Go, where you can start from a fairly simple like syntax like this and then evolve into complexity later. And then you immediately get sticker shock. Even though, and whilst an experienced developer might be able to look at what you've got and say, oh, I can see how this can increase maintainability later, or I can see why this organizational structure makes sense. Many also are not able to do that. And then lastly, and this is the one that most people actually like, this is the one that is less obvious, is there's a lot of apps you actually can build these days that don't require all of the techniques we have to manage complexity within your process boundary. So if I think of building microservices, for example, where you're splitting your application across many smaller interrelated pieces, any individual piece of that may well be fairly simple. In fact, in an ideal world, it would be. And things like, tracing and distributed tracing and diagnostics, maybe auth, like lots of concerns like that, you start to push out into more networky concerns, depending on your environment. But there is certainly a world where you're using a mesh network, say, where a lot of concerns that would have made added complexity to your application are taken care of outside your application. And as such, your in-process code that you're writing here can actually often be not that complex, or at least focused enough that it doesn't make sense that you don't need a significant amount of boilerplate around to manage it. And so now you have the flexibility to do a bunch of that. So let's jump over. This is normally when doing this, this is a little bit old now. I do need to update it, but one of the things I do when doing this talk frequently is I'll start with that empty and then turn it into this. For this sake, I'm just going to show you the end state. So the idea I was trying to build here is I'm going to build a little service to add to my solution, which people can send feedback to me about the app. Maybe like a button at the top of my app that says send feedback today, right? And so, okay, I want some open API. So I've still got the same builder. So this is the same as down here. I have still do builder.build. on my builder, I can have my services collection, so I can register services like you would do in the configure services method today of a startup CS if you've been playing around with ASP.NET Core. This here is about how I use Mongo. I create a client connection, create a database. I have config. See, I can grab my config from the builder. I could decide to put these into DI if I want to here. I could say builder.services.add, but I can also just use them and capture them because this is all one file and they're single. As long as they're singletons, then they're singletons here by using them this way rather than putting them into DI if I don't want to. But I could also put them into DI and inject them down here if I want. And then effectively down here, I'm just saying app.map. What do I want to do? I want to say ping hi. I want to map a post. If somebody gives me a report, I want to be able to put it in a database. And if I catch an exception, I want to return a bad request, right? I want to get based on ID. I want to do a find, right? And then down here, I declared this like inline, feedback view model as my wire format to be able to take data in. And so this is not like, there would be a little bit more complexity probably if this was real, a little bit more error handling, but otherwise it does most of what you would do. I could see a small service like this existing. I'm positive I've written small services like this that have been deployed in production at various points in my time as a dev before moving to where I am now. And if we compare and contrast this though to where you would be with controllers and MVC, there would be a controller, a class. So you would open up this project and there would be a folder. There would be a program.cs, which you don't care about anything that's in. There would be a startup CS, which you care about a little bit. And then there would be a folder with a controller, and that's what you would really care about, but it would be the only thing in a subfolder to compare and contrast, right? And so it would feel pretty verbose. Right? And then, this also uses Docker, and typically I use the container tooling in Visual Studio. If you've not seen the container tooling in Visual Studio to be able to like spin up and spin down containers easily, I apparently don't have Docker Desktop running, so I guess I won't be F5 in this. But I usually use the container tools in VS to be like, spin me up a Mongo, F5 this, and call life good. And so that is a whirlwind tour of how much simpler and easier the newer way of approaching this. So a few things that are not super obvious. This gives you model binding like MVC's model binding, but it doesn't go through a significant amount of MVC's pipeline, which does mean it will be faster than mapping to a controller today. So things like the filter pipeline that exists in MVC doesn't matter. It doesn't exist here, and it isn't required because you've got middleware which does that. So MVC, for those of you who don't know, you have middleware, then MVC starts, then MVC effectively has its own set of middleware called filters, which are MVC aware. None of that exists, which means all the machinery and the complexity around having to spin that up and boot it and put your request through that doesn't exist, which means you're not doing as much compute per request, which means faster, right? And that's kind of a happenstance. Like it's always a goal to make things faster, but it's not like we were explicitly trying to ditch that stuff from MVC. It's just that we're starting with what are the most useful components as we decompose MVC, so it's less monolithic and more able to gain those features that I want everywhere. What does that look like? And you grab the most important features, and the most important features are things like model binding and return types. You want to be able to bind to a type and return okay. And so you ditch a bunch of MVC stuff that was specific and unique to MVC. Or it was serving a double purpose, like filters really are just middleware that know about MVC, and you don't need them now because you have endpoints. And so Hunter, I just talked about containers and being able to F5 and use Mongo. That seems like a good tangent to talk about something else we have that runs an app with a database, with a container as a backend that you might have a demo for. Do you have a demo of that? Or if I talk for 5 minutes, will you have a demo then?
I think my stuff works today. I was actually just agreeing with somebody in the comments about, I think they're running Thai and they might be stopping it and restarting it. And that ends up not being a great interloop scenario as well. I was hoping you were going to show some hot reload there somewhere.
Yeah.
So,
oh, okay. Yeah. I don't have a hot reload.
I'll put pressure on you to think about that. And I'm going to switch back to slides because I have slides on Thai.
So,
and there's
while
folks
that's spinning up, there's one there was one question in the chat that I said I would address, and I haven't yet. And this might come into your stuff, Hunter. So the question was specifically, just before I started, it was from Simon. My understanding is that the size of .NET Core microservices is very large compared to the Go equivalent, allowing Go to gain substantial in the microservice space. How is .NET Core going to compete with service when service density is so critical? So I don't have a demo of this, but we do have a benchmark that we've run internally to specifically measure how good we are in high density scenarios. And it was something we did work on a little bit over the course of the current version of this version of .NET, and we'll continue to get better on in subsequent versions. That we actually did really well in that demo, that benchmark, but there was work that we had to do. And we are continuing to do more work in it. Go is the obvious competitor because they're the ultimate kind of target. They're compile very small, they compile natively, they are kind of the ultimate target. We are at the point where you can run, a few 100 megabyte microservices or 100 megabyte microservices, and they work well, and they do reasonable things. So we are now significantly better than we ever have been in the past, and we can expect to continue to be better than we ever have been in the past without you even realizing that it matters. So the outcome is that you just deploy your thing and you configure the constraints to be the constraints that you want, and it just works.
No, I think I
The only caveat of that is occasionally there's a config switch that we really can't choose a good default for. So I would also expect, as much as possible, we're going to do the right thing and it's just going to work. Occasionally you'll get into some scenarios where you might need like a GC flag or a GC switch to be able to get into that really good density world. And in those cases, we've committed to adding those configurations, whereas historically we would always never add those. And if you wanted to talk about that, Hunter, I know you were deeply involved in a bunch of those discussions with people about the philosophy of adding more GC switches versus not adding them, for example.
I like more.
Yeah,
I know. I was just going to say that even more explicitly than Glenn did, we actually ran a huge thing. It was probably about a year ago, I think it was, where we actually ran benchmarks across Java, Node, .NET, Go, Python, and we benchmarked across a bunch of scenarios on minimally constrained machines, machines with lots of RAM and stuff like that. And there's only two techs that survived the entire benchmark, and that was .NET and Go. We've always said we want to publish that. We just haven't found a way to. We also don't want to throw languages under the bus. For example, that particular demo showed that Java, needed a gig of RAM to get off the ground, while .NET would get off the ground in under 50 megs. And so if we can find a way to show that without, we don't want to be language snobs or platform snobs anymore. That's, we believe in, we know that the world's polyglot. Some people's apps will hopefully be .NET. They might be other stuff. And so we're trying to really not be, negative. And so I'd love to show it, but I want to find a way to do it tastefully that nobody goes, oh, you're trying to make Java look bad.
Yeah, we need to, and I mean, there's, to that point about configuration options, there is so many configuration switches and dials in Java and in the different Java JVMs and such that I'm sure there is a way to tune it to make it work much better than what we had. I don't know what it is, so I need to get the right Java experts in to take a look. I don't want to compare .NET to poorly tuned out of the box Java. I want to compare it to like an expert who has looked at it and made it as best as we can, and then see how good we are. That's what I'm trying to achieve. So compare myself to as best as I can find.
I'll let Glenn take over the chat, and I will go back to the deck. Yeah, and so we'll talk about Project Tie, which is something that we started. This feels like 2 years ago too, Glenn, but maybe it's a year and a half ago. One of the things that we recognized as a team was, building multi-project apps is just not good. It's not good from command line. It's Visual Studio has some tech in it that lets you actually decide to, have a solution with multiple projects, and you can tell it to start all the projects at the same time. We know there's work to be done there, and that's future work that we'll do in Project Tie anyways, is to go figure out, the goal of Tie was to go figure this out from the command line, and then go find a way to retrofit it back into Visual Studio and Visual Studio Code to give a great experience. But there's a couple of things that we try to solve here. Is, like if you look at the diagram here, I've got 3 services in a front end. Well, how do you do service discovery? How does the front end talk to each of those services? That's a challenge. As soon as you want to start adding dependencies, one of the amazing things about Docker is, you can actually run, Microsoft SQL Server on a Mac in a container. And so, historically, as developers, we would just go and install all this junk on our machines, and I don't want to do it. I don't want to manually install SQL Server on my machine and never know if I could take it all the way back off again. So running it in a container is easier. So with this is, we have a way to easily let you, manage your dependencies via containers. But once again, we don't want you to write Docker files. We don't want you to write Helm charts. We're not ops people. We're just developers. And so we want to find a way to let you describe the app and build it easily on your local machine without, all that tech. We also want you to be able to run locally. Ty lets you run it 2 ways. You can run native, which will give you the best performance. And you can also run inside of containers, which can mimic what your production is going to be. And so we let you run and debug locally inside of containers. And then, we give you a dashboard where you can look at the metrics of your application, logging, and all that stuff directly from a single panel. You can find the endpoints for all the pieces and stuff like that. And then finally, I think the final piece, which is when I had that awful slide showing all those Kubernetes pieces, we want to enable you to basically take all those containers or all those applications and easily Dockerize, containerize, and deploy them to the cloud, kind of as a unit. And so that's what Project Ty is all about. And I'm going to join from my second machine because this machine does not have this stuff on it. So let me do that real quick. So just give me 1 minute to join the call from my secondary machine, and I'll share the screen from over here. Glenn can provide entertainment while I'm.
So I am trying to answer people's questions in chat. If you have questions for me or for us, or if I've missed your question, like throw it in again, and that sort of stuff. And I will type stuff to people.
I'm now having a Glenn challenge.
Yeah, excellent.
Page you were trying to access cannot be loaded.
Yep, Defender. Yeah.
Yeah, is that what you had too?
Yeah, I use Chrome instead.
You what?
So I switched from Edge to Chrome.
I don't have Chrome on my machine. So maybe you can do a hot reload demo while I'm getting my machine ready. If you have something you can demo.
Pretty sure I use every browser I've ever built is on my machine in some form after being a web PM for so long. In the absence of web, how does a version of control work? So what is the Chrome of which I speak? Man, okay. So in the absence of web API controllers, how does inversion of control work? So I guess there's a few elements of that, right? Like MVC and as such, and web API, which is a kind of special case of MVC, is an inversion of control framework for everybody who thinks of inversion of control purely in terms of DI. And as such, what that means is the framework calls you, it instantiates your things, you just declare code, and then it'll call you at the appropriate time, right? And so because it's kind of function based, that's different. You can still use DI to inject services into the function calls, and you can grab stuff from DI if you're thinking of that aspect of inversion of control. If you're thinking of the aspect of inversion of control about how the framework decides to call your code, because it's function based, you're mapping a URL to a function, so there's less kind of, and we invoke it at the right time, right? So you have it is still, that inversion of control still exists, but it doesn't have as many problems or interesting wrinkles as kind of class-based, object-based IOC, if that makes sense. I don't know if I touched on all of your questions. So in terms of unification for .NET 6, will Unity be switching over to .NET 6 instead of Mono, or what's the plan there? So we don't actually own Unity. It's its own company. And so they will do whatever they think is best. We are committed to trying to make sure that .NET 6 is an amazing platform that they are capable of moving over to should they choose to. And we would like to make it the best platform, best and obvious choice for them to jump over to. But ultimately, that's not our call, right?
They do plan, Glenn. There is a plan for them to get to the newer bits. For them, it's a breaking change for them. And so it's something that's about a year out from now is where they're currently at. But I can envision a future where they're not on Mono anymore. They're on the same .NET 6 or .NET 7 bits that we have. We were just talking last week. This is super NDA, or it's not really NDA. We're just talking about it, but it's very easy for us to make .NET 6 target Xbox, PlayStation 4 and 5, and so you're going to start seeing us add the gaming platforms to .NET, and as we do, it will enable the Unity folks to move over and use the newer tech.
Yeah. Yeah, that's kind of what I meant by us being able to make the platform be something that they're capable of doing. But I didn't know how far along talks and decisions and ideas were in terms of actually doing that. Sounds like we're talking about it, and we will hopefully get to do it.
Okay.
So can minimal APIs work with Azure Functions? I wish that you could take your minimal API and drop it as is as an Azure Functions. Not really. Not. You couldn't take this program CS and use that as a function today. You would still need to use the Azure Functions kind of programming model because that's because of the way that Azure Functions is implemented. It might be something that we can get to in the future, but it would be a big change for Azure Functions, so it will necessarily lag behind the implementation.
I think you should say it as a goal, though, Glenn. We want to get there.
Yeah, but unlike you, I'm not in charge of the Azure Functions team. So, yeah, this is the way I talk about partner teams.
I am. Last time I checked, at least the PMs on the Azure Function team now work for me. So
yeah, and so yes, there's a general tension between Azure Functions about how close Functions is to a normal API that you could build with ASP.NET Core versus like their own kind of special programming model. And they are their own one. It's not super special, but they are their own for better or worse. And there is a general desire to make them be more and more like a vanilla ASP.NET Core API, however that happens to be. But there's a lot of work involved in getting that to be the case. So no promises on timelines, but there's always a desire to make your Functions API feel like a normal ASP.NET Core API when doing those type of bindings, at least HTTP bindings.
So this is the traditional tie demo that we've done for a while, and I can come over here. Oh, come on, give me a break. Sometimes Zoom is uncooperative. And if I launch like VS Code, what you're going to see is I've got, and I apologize, both Glenn and I are both terrible demoers using dark theme for our demos, Glenn. So that's a fail. What I've got here is I've got two applications. There's a front end and a back end application, and it just highlights the problems that you have with this kind of scenario. Obviously, in Visual Studio, I could go run each of them manually. I could run both solutions at the same time. But what you might do over here is you might do a .NET run. It would be helpful if I was actually in the right folder. You might do a .NET run on the front end, and maybe a .NET run on the back end. And when you do this, the first problem you're gonna realize out of here is we're gonna have challenges with discoverability. The back end is running here on port 44320. The front end is running on 44367. if I go look at my code over here, I'm still I'm coded to 22230, and that's because whatever developer machine, this might have been Glenn's machine that wrote that, grab that URL, that port, and of course, if I run the application, it's going to fail miserably because it was not able to find the back end, so it crashed out. That's exactly what you would expect. And so lots of errors, lots of goop, yuck. And so I can stop all that. And where Thai gets a little different, the idea behind Thai that makes this a little different is it's an environment for letting you describe your entire application. So first off, what I can do is, let's fix this hard-coded port and address. What I would do is I'd go to my front-end application, and I'm going to add an extension package here. We'll build this stuff in the long run. And quit complaining to me. And this gives me some simple extensions. And with those extensions, I can go make some small changes, like instead of hard coding, I can just start naming things based on the name of the project. So notice here, to get the base address, I just say, give me the service URI for the backend. And that's because we're basically looking at these things named on the base of the projects. So we look at the name of the project, and that's how you name things, and you just call things based on those names. So with that one change of code, now I can go back to my command prompt, and I can do a Thai run. And what that's going to do is, notice I'm in the top folder. It's going to go find all the .NET projects underneath here, and it's going to go start them all up. And let me just do this too, since we're doing video and everything else. Let's make the fans run really good. And there it is. There's a clickable link there. And that's going to bring up my Thai dashboard. And typically in Visual Studio, if you're running multiple projects, you get nothing. You don't know anything about anything. But you can see here that we're actually giving you the addresses and the ports for both non-SSL and SSL for both the back end and the front end. I can go look at the perf counters for the application right here. I can go look at the logs for each of the applications. So, this is an experience we should have built into Visual Studio a long time ago, but we haven't. But now I can go click on the front end application, and now the app works because no matter what the ports are generated by the projects, that service discovery that you saw from over here just makes that work natively. Now we mentioned something earlier. We mentioned about, well, I need other dependencies on my machine. How do I manage those? So I can go back to the command prompt, and I could do something like we call Thai init. This generates the config file that Thai uses. By default, it was making this up on the fly based on the folder structure of my computer, but I can go back into VS Code, and down here there'll be a Thai.yaml file, and you can see we've now put in text what you see here. There's something called the front end. It's based on the project, the front end CS proj. There's a back end based on that. And so this kind of declares what Thai was learning by itself and doing for me automatically. Now what's cool here is this is something we need to work on to make it easier, but I can go add to that. And so I can come over here and say, in this case, instead of saying it's going to be a project like it is here, it's an image. That means it's going to go out to the Azure Container Registry. It's going to pull that image and run that as a container. And this is where I don't want to install Redis locally. First off, Redis is a Linux. There is a Windows port, but you really want to be on the Linux version. And so it's a container that can run on my local machine. I can make that change. We can go back to our CS proj. I'll bring in the Stack Exchange Redis client there. Go back to Startup CS. And what I can do now is I can actually add the dependency injection to bring Stack Exchange in. And once again, you're going to see the configuration is all done by name. And so in this case, we go and get a connection string. because it's not a service. It's an actual connection string to the Redis cache, and I name it by value, and I don't have to worry about what ports and stuff it all came up on. That was described in the YAML file, but we don't want the app to care about those kinds of things. And then the final piece here is, now that I've done that, I can go over to my view, and we have a tag helper that we built all the way back early in .NET. And what this tag helper is, it's basically a cache tag. And so you can see here we're saying, hey, we're going to call this cache the weather cache, and it's going to expire after 5 seconds. And then anything hosted inside of that tag helper will be cached for 5 seconds before it runs again. And I can go back to the command prompt, and I can do a tie run. And I'm not going to show it, but I could do a tie watch here as well. I can do a tie run watch. And that means I don't have to start and stop every time. I can actually just keep the app running and make changes, and it'll restart as appropriate. Now this time, you're going to see a few more things here. Like that. If you go here, look here, there's Docker networks, Docker images being booted up. So there's a bunch of other infrastructure that just happened underneath the covers here for me. I can go back to my dashboard, do a refresh of it over here. And now there's the container. And you can notice that these two are projects. This is a container, it knows the difference. I still have the ability to view logs and stuff like that. But now I can go to my main point here. And as I'm refreshing it, I'm actually clicking it a bunch of times. You can't see that, but you see it only updates every 5 seconds. And so in this case, I went and installed a third-party dependency without putting junk on my machine, all in a single file. I didn't write Docker files, and I have this nice composable application. The final piece of this is now we've got a container, we've got a front end and a back end. What would I do next to get this tech to the cloud? Let me stop this. And somebody in the chat earlier was saying, hey, this process here, notice it takes a while for all this to go down as we go and nuke the containers and stuff underneath the covers. This is something that we definitely can make the inner loop for this better. I said there's a watch that makes it a little better, but I can do a tie deploy -I for interactive. And what this is going to do is it's going to let me basically publish this to a full AKS instance running in Azure. So if I go back to my browser, I have a tab over here with all of my stuff here. You can see I've got, in case we want to show stuff, I've got a Linux app service, a Windows app service, I've got an API management, but I've got an AKS, I've got a Redis cache, and I have a registry, a container registry. And so what it's asking me here for, it's asking me, hey, can you give me the information about your container registry? Because it needs to know where to publish the containers to. So I'll put that in there. And actually, I'm going to cancel this because Glenn, I always screw this up. Let's go do one more change over here. Go back to my tie YAML. A thing about running in Kubernetes is you have to have something to let the web traffic get out. And so in this case, it's an ingress to let you in. And so what I want to do here is basically do some port mappings. Let's not do that. I need to do some port mappings, and these are examples of things we can tool for you and make better in the long run. But I now said I've got an ingress. It's bound to port 8080, and the service I want to expose at the root of that is the front end project. And so this is the magic that lets Kubernetes let you have access to the service. And so let's go run this one more time. And while we're waiting for that to start up, I will go copy the registry back to the clipboard again. It's going to ask for that again. And so it's doing magic container stuff here. So what's going on here is it's basically telling me I don't have access to the container registry. So I just went and scrolled back up a couple of times and said, hey, log my local terminal into the container app, the container registry. Try one more time. You can see it's not fake, it's real. Hopefully I've recovered Glenn. See if we get further this time. That looks better. It's publishing my image to the cloud. Now notice it's asking me for the connection string to use for the service Redis. Locally, I ran Redis Cache in a container, but Ty is aware that Azure has a service. You really don't want to run your own Redis in a container because you have to manage that thing. The service that we have in Azure is managed for you, which means if the virtual machines it's running on decide to go down for whatever reason, we will boot it up on another machine, transfer the cache, and that'll all be transparent to you. And so you're better off trying not to run these things by yourself. And so it's going to want me to go back to my dashboard here. I can go into my Redis and I can go to access keys, grab the connection string, put that in. That means when the app actually gets into Kubernetes, it's going to point my app to the actual service in the cloud versus the one that was running in a local container. And all the connection strings will happen automatically for me. This is something that Glenn and I used to demo, and it drove us nuts. Is notice it says waiting for ingress to be deployed. This can take a long time. Used to be that Ty would actually stop as soon as it got to this step, and you wouldn't know when you could actually call the actual service in the cloud. And so there's been code added to Ty that actually waits for this to complete. I assume we'll have a feature where you can tell it not to wait, because there might be times when you don't want to wait for that to happen. But notice that not only did it wait, it also gave me an IP address. And I can grab that, copy it, come to my browser. And that is the same application with the front end service, the back end service, all running in Azure. And if I start refreshing the screen, I'm pressing refresh in the browser. Note that things aren't changing, they just changed. And that's because it's actually using the real Redis cache in the cloud. And that shows you how easy it is to take a multi-part application, run it locally, using third-party dependencies, and to be able to actually publish all that tech to Azure in a couple of simple steps. Somebody in the chat earlier mentioned Dapper. And Dapper is a technology that lets you make API calls across applications, and it handles some of the authentication and stuff for you in those scenarios. You can use Dapper to actually cross-call between, let's say, a Java app and a Node app and a .NET app, and you can do all that for you as well. And so Ty is a great technology for building these, multi-part apps with Dapper. And so as we start pushing Dapper more and more, you'll see them talk about Ty a lot more as well. And we'll do a lot of work on the inner loop there. So that, I'll ask Glenn, what did I miss?
No, I think you missed a lot, but we could do a bit of a question roundup. I've been leaving a few questions because I figured we could answer them in person and talk backwards and forwards. First of all, the most important question is, when will we not call 118 Fahrenheit bracing? I don't know. It seems good enough for me for now. It's actually purely random. That data, it doesn't actually mean anything. And people.
Which data? I didn't hear what they said.
The actual we have the text bracing next to 118 Fahrenheit, which is probably not, but that's because it's purely random. So the first serious question though, service discoverability is developer time only rather than something like a service mesh. So service discoverability is config based. So there is an extension method on configuration that will accept a service name, and it effectively looks up a config key, which could be an environment variable, which ultimately is an environment variable in Ty. It could be whatever config when in your deployment platform of choice. And that config key has a particular name format. It's like service aim underscore the name of your service, and it has like a format of what the key should be. So you could deploy this app anywhere, as long as you can set the config to point the different things to the right places in your deployment environment. In the case of Kubernetes, we take care of doing that using Kubernetes configuration objects for you in that deploy step. And if we were to support other deployment things other than Kubernetes, we would do the same thing for you again, do it automatically. If the place you were going to had a deployment mesh and had like a mesh and you weren't using it in your dev environment, you could use the same system, and the config keys would just be the service name again, and then the mesh would take care of resolving it, for example. Thai doesn't explicitly do the question was, how does Thai recognize service dependencies? Example, first start BE, then FE. It doesn't actually do that yet. Eventually, if it was to determine that, it would have to do it via some form of expressed in the config file some way. I don't believe we ever got to putting depends on. We certainly talked about it a lot. Maybe we did just barely, but I don't believe currently it actually expresses that, and it just lets everything start. Yeah. Is it fair to say that Project Thai is to VS projects what Docker Compose is to different Docker containers? Yeah. I mean, Thai is not currently in yes, it is. Sorry. Yeah, that's one way to look at it. Absolutely. Like, it gives you the ability to have multiple projects and depend upon containers as a startup like artifact, which is nice. David says all that red text makes him panic. Me too. But Hunter showing us all up didn't make him scared at all.
I'll show a couple other things while we're just chatting here. Notice I can also do Thai run -- Docker. This case, what will actually happen is we'll run every single part of your application in containers. And so this is trying to mimic exactly how the actual service in the cloud was running. And so it'll take more time for it to get booted up because it's got to make some containers locally and boot them up. And I'll go up there and grab the dashboard. Well, I already have the dashboard running, I think, still. And now you'll notice that the dashboard is showing everything with a container. And so that's another way of running Thai. An even cooler way of running Thai, notice that I'm stopping and starting Thai. That's not awesome either. This is kind of slow and chunky. Now it's nuking, there you go. So I can do Thai run, and I'll do -- help one more time. And notice that there's an option here for watch. And so in this case, I can do Thai run -- watch. And what we'll do is we'll have watchers running, which means as you want to change one of the applications, you don't have to go and start and stop and start and stop. We'll restart on the fly as you make changes. But in the long run, we want to make this tech awesome, and then we want to find a way to get this tech into Visual Studio. So as a Visual Studio user, you get all the experiences of this to build these multi-part applications.
We also definitely wanted to support things other than Kubernetes eventually for that question. We don't support anything else yet, but there's also not very many good options around today. But we do support functions and serverless within Thai. And so today, we only support those on the developer side. We didn't get to the point yet where we deploy those to functions or something to a serverless backend. But you can use Azure's functions specifically are one of the extensions that it has. So you could define an Azure Functions project, and we'll take care of spinning up the Azure Functions emulator and such and running your function. We haven't done any deployment step to send that. And we also don't have, we obviously, if you're going to do that, would also want to then collaborate with people like Lambda to have that serverless platform also work, which we haven't done. But they're all things that we have talked about and would be interested in doing. Just backlog prioritization, right? Same as everything else. Did Thai just automatically create Docker images for those projects and run them as containers? Is that what that command just did? Yes. That's what it did.
Alexa, chimney stop. Alexa, chimney off.
John, you unmuted yourself, mate. So yeah, that's what it does. So that's an interesting point, actually. So some of the things that Ty is doing also should become more common. So this is maybe a bit of a spoiler, Hunter. Should we talk about generating containers in .NET in the future? What do you think?
Yeah, we should.
So one of the things that I think, I've got a paper being written about this now, and one of the things that I think we're going to do in .NET 7 is actually support something even more kind of automagic than that. So what Ty does today is we know what a .NET Docker file looks like. We know, right? So for like 90% of cases. So Ty can just generate that and then call Docker build on it. And then you don't need to care about it, right? And it'll do it on the fly for you and work it out. Or you could give us a Docker file, right? But we believe in the future, what we want to provide is the ability to build a Docker image and push it to a Docker registry without necessarily even having Docker on your machine, without having a Docker file, and just with the .NET toolchain. And so what I'm proposing that we're able to do come say .NET 7 is effectively .NET build, -- Docker, or perhaps have a setting in your CS file where your output is just an image that you can then upload to a registry, and it will use kind of the OCI image, the Open Container Initiative kind of image formats, being able to generate those, fire those, put them onto disk, and you could. It should be probably faster than doing a normal Docker build, with the known caveats that you're not actually doing a build inside of a container, because for the most you can't run basically. So you can't do anything that requires an apt-get or any of those sorts of things where you have to pull down a dependency in order to do a build. If you want to do that, if you have some sort of runtime dependency that needs to be installed in the OS, you would need to do that as a base image, and then you would configure your CS pros to say use this base image instead of the defaults. That's the one kind of wrinkle, but it should be faster. And it shouldn't require any of the Docker ecosystem to be able to do it. And then if you want the Docker ecosystem, you can go ahead and try it out. There is some experiments in some other language. There's some other experiences in some other languages stacks that are similar to this, but not as deeply integrated. So things that spring to mind are Google have a project called Jib for Java, which does something similar to this via build packs, but it's kind of add-on and it's not just baked in. And so like we're saying that where the statement that I think we would make is, it has been said across the industry that containers will become the unit of deployment of the future. Even if you're building a monolithic web application and deploying it to app service, you'll probably use a container as your deployment artifact. If that's true, why can't .NET just make them, just like it makes a binary, if a binary is your deployment artifact of the past? And that's the future that we will try and push towards, where you just do .NET build, you get a container and deploy it, and away you go.
Yeah, there's huge benefits there too. There's no Hyper-V required. The perf's going to be a lot better. I mean, there's improvements across the board from that, and I will
Yeah.
just because I think it's something we've been shipping for a while, but I think people don't recognize that it's there. Probably it probably doesn't get the justice it deserves. Here's my machine again, and here's Docker desktop, and what I want to do is I'm actually going to go and turn it off. So we'll quit that. And the point I'm making here is I don't have any, it'll say updating and it'll die at some point. Let's make sure let's see it's going down. I just want to show this without any of these these things working. Don't know why it takes so long to turn Docker off, but it's another reason, Glenn, why we don't want Docker.
Yeah.
There we go. So you can see Docker is stopped. There's no more Docker running. We mentioned WSL before. I can just type WSL, and now I'm in a regular Linux bash shell kind of scenario here. This lets you run Linux on Windows. And so here we are in a VS application, and I run it, and it's super fast. And you can see it's running on Windows NT. That's what you would expect. All the app actually does is just writes out some operating system goop to the screen. right here. But if you've not seen this before, there is a drop down here with WSL. And we supported this in Visual Studio for a while. And you can default yourself to this mode. And now when I run the application, you notice how fast, it was just as fast as running on Windows. Now it says it's running on Linux. And so there's no Docker running, Hyper-V is not required on the machine, but I get this amazing, very, very fast, Docker experience, and everything works just like you would expect it to work. I could put breakpoints in if I wanted to and run the debugger. All of it will work. And so I think that's kind of cool too, Glenn. That imagine this scenario is I run locally, I use WSL to develop on Linux, and then I publish, and we just publish using a tool chain that does not require Docker to be on the box to make the container.
Yeah, absolutely. And yeah, that's kind of I think that's one of my kind of end games. And if there are any MVPs on the call who have watched any of my talks at the MVP summits in the last couple of years, you'll have seen various prototypes and demos and like stuck together with, string and sticky tape versions of that kind of generate images on the fly. But the ecosystem around being able to do that was never quite mature enough to pull the trigger on really integrating it properly. And we think they've reached a point now where they are. And as such, we can do it. Previously, for example, it was impossible. The first time I tried to do this, for example, it was impossible to use OCI tech on Windows because the whole dev team working on it were all heavy Linux focused, for example, right? Now that's all matured a lot.
We could require WSL for that feature, Glenn, easily. And
we could easily do that. Yeah, WSL is now exists, which means when any parts of it are particularly heavily whenever any particular parts of it are heavily and require Linux, we have an option now. There's a lot of the tech has advanced in the last couple of years to make it possible to do this. Make it possible to do it in a good way. It was always possible to do it as kind of a bolt-on thing you could optionally do, but the core experience of .NET is just you say, yeah, I want a container, and you just get one, and it works, and it's good, and it's as efficient as possible. Getting to that point, it's not really been possible up to before now.
We'll do it. I think in .NET 7, as you said, I think we'll get there, Glenn.
I think so. That'll be the proposal. We'll have a big paper written up, and we'll probably how do we feel now that Docker has changed its licensing? I mean, fine.
Once again, they're a business that builds software and makes no money, and so if we want Docker to keep to exist, if you want the features of Docker Desktop, they need to find a way to make enough money to actually afford to build that tech. As Glenn said, we can remove our dependency where, you can at least publish without that stuff, but you're still going to want some piece of tech to let you actually run locally and.
Yeah, that's right. They for a company that revolutionized so much, revenue stream seems like an important thing for them to have. I don't begrudge them that. I want to keep seeing all the cool tech they build. So, yeah. But also the Docker ecosystem is becoming more and more open and less contingent upon Docker, the stuff that the Docker co-op builds. And so we'll see how that evolves as well.
Yeah, Jonathan, I don't think that their strategy was to get everybody on it and then start charging for it. Honestly, if you look, they've been taking money rounds for years and years and years. They've been, they charged for their container registry. That wasn't a big enough business, and so it's. I feel bad for them that they started off without a business model, and then find out that they don't have a business model.
Yeah, but I want them to be able to make money. Everybody should be able to make. Anybody building such great technology should be able to make money off it and continue doing it. So I want them to be able to find a good way. Just like anybody who creates a cool open source project that is great and gets used by lots of people, I want them to find a way to make that financially viable as well, right? It's not much different, really.
But yeah, serverless is a great option there too.
Yeah. And so I think we're almost at the end. We could do a really quick, make a new Razor Pages project and do a hot reload. Or if there's other questions, we could answer more questions.
Oh, come on, Glenn, do the demo.
Do the demo? Okay. Let me open up Visual Studio.
You just put yourself on the hook as soon as you said, "Oh, we could do this."
Yeah, I think you might have to do the demo.
Damn. Okay. Next time, note for next time: don't volunteer to do anything. So there was a, if you scroll back up, there's a question about unit tests. Yeah, you can absolutely write all of your unit tests. There is a, if you scroll up, there's a, like a cheat sheet from David Fowler, a gist that I posted where he has some examples of doing unit tests, I believe. If not, if you grab that and it doesn't have it in it, let me know. But yes, you'll do unit tests. Yes, there will be a way to do it. And we would have examples and like documentation and stuff. And it actually looks pretty nice. Some of it looks real good. Some of the unit testing work for it. So I guess I better share my screen because I'm being peer pressured into doing a demo. Where's my, hey, Zoom, hello. Hello. Not responding is not what I want to see, Zoom. No one will believe me if you don't respond. Everybody will think that I'm just using it to copy out of doing a demo. Okay, so here's Visual Studio. This is the default Razor Pages app. So all I did do, if you want to play along at home, all I did was file new Razor Pages, right? And so in index.html, we do that. I'm gonna Control F5. And then I will drag once a window appears, wherever a window appears on one of these monitors. And I believe when I ran this, when I ran Visual Studio last time, Zoom was nice enough to tell me that all of the resources were being used on my machine, and as such, everything will be impacted. So forgive me if this takes a little while to get a browser up. So this is my, whoa, that's the Chrome thing that I did earlier. This is my my app. Go up, Visual Studio, please. Bloop. So this is the app that I just ran. Welcome Web Application 22, the best web application. It's going to change the world. So I can start doing stuff over here like I love demos. And I can save and I can go bam, right? And then I can start to get prompted here to say, hey, that edit you did, not quite. So the thing about hot reload is we will tell you when things are going to work with hot reload and when they're not going to work with hot reload. Okay, so if you get that's what that dialogue means. So let's, in general though, the idea here is we can start to define things like a message equals demos, right? And I can like do things like over here in my index, I could say div, right? I could say at model dot message, right? Capitalization, that's the correct capitalization. I don't want to hear it from any of you, okay? I know what you're all thinking. And then I'm going to like F5 it again. And I have demos. And over here, I should, in theory, be able to change this, save it, and say, change it. Bam, demos, right? I'm not sure why I got this hot reload pop-up. I'm just editing. So you can see over here, as I'm changing code, I can save the file and it'll go bam, and immediately my browser over here switched to say demos, right? And I'll have to figure out what exactly this thing is doing to me. I'm sure it wasn't doing it earlier when I did this demo. But anyway, that's the basic premise of hot reload, is there is a bunch of work that we're doing to allow it so that for a bunch of like non-rebuild required change types, you'll be able to just change some code, go over to your, and change some code here and have it just appear over here. Similarly to how, you know, HTML changes back in the day where you could just kind of change them and refresh and you would see changes over here. Now, you'll be able to do that same stuff, but also with things like C#, like the demo I just showed you was this C# demos being changed, right? And so that is ridiculous. And so here is the ultimate experience, as I just said. As I'm typing, as I click save, I'm saving some C# and it's changing on the fly. Look at that.
I will screen share one more time, Glenn. And just kind of end with this.
So that hot reload stuff, by the way, yeah, you should be able to try it now if you grab the newest Visual Studio. Ultimately, the idea is eventually you're just writing code, and as you're writing code, you're seeing the outcome, and as close as possible to that as we can get. As you just saw, when you're editing, or I can just type code and the browser changes, and that's amazing. Right? Or I can click the button if I happen to do an edit that doesn't quite record.
And we're going to make it work everywhere. Just to close out, don't forget .NET Conf coming up on November 9th through the 11th. It'll be the .NET 6 launch. A bunch of us, bunch of community, a lot of cool giveaways and tech. So and please come watch. And then finally, thanks for having us today. And you can reach either of us at on Twitter at CoolCSH or at that is.
I'm not sure where the F came from. Yeah, there's a G at the end of Condren G. But yeah, you can grab me on Twitter. I like to say I have about 100,000 unread emails, but no unread tweets. So you can try and email me as well if you want, but good luck.
Cool. We both have to run, but thank you so much for having us, and bring us back next year after we ship .NET 6.
Thank you so
about
much,
.NET 7.
Scott and Glenn, as well, for your time. And Glenn, I would like a .NET hat if that's ever on the offering. But thank you so much, both of you,
This
for your
one here?
time. And we'll hopefully see you soon as well.
This actually has my name on it. I got it custom made.
Oh
in
my
Vegas
lord!
for
What
Mine has
what
my
do I need
handle
to
on it.
do?
Oh,
only three of them exist. Me, Scott Hunter, and Brady Guster.
I will spend money on a flight to Vegas just to get one of my own.
Yeah.
Well, cheers again,
All right.
guys. For everybody else, we will get the recording out in the week. And also, something to be excited about is in November, we have our first face-to-face meetup since the pandemic. Woo! So we will
Nice.
be
Woo.
joined by Steve Sanderson, who is the program manager for ASP.NET. And he will be at Microsoft Reading. So very, very cool and very exciting for us. Once we get all the risk assessment done, as you can imagine. So anyway, look out for details for that. And we will also be mixing it up between virtual and face-to-face. So keep an eye on the meetup pages, keep an eye on the LinkedIns, on your inboxes, and we will be in touch with more details. And last of all, thank you for everyone for coming. I think we topped out about 160. So really good to see so many familiar and new faces as well. Take care, and we'll see you all soon.